Okay, hi everyone. So this is the video for the solutions to the March 25 worksheet. So the first question again is a review of RNS, and you can see it's this carbon, this carbon, this carbon, and this carbon that are the chirality centers. And once again, we need to add the H's in because they're not all drawn. So this one has an H back, this one has an H back, this one has an H back behind, and this one with the fluorine, however, the H is up in front. And now this is going to get a little bit messy. So I'll put the A, B, C, and D on this first one and on this last one, and then the middle two I'll just sort of talk you through them. Again, remember it's the four groups bonded to this central carbon. So chlorine is going to be A, that's number 17. Hydrogen is D, that's number 1. Oops, D. We have this carbon with 3 H's and this carbon with 2 H's and another carbon. So this one is going to be B and this one is going to be C. So again, A to B, B to C. So that is clockwise, and your H is where it's supposed to be in back. So that one is R, okay, for this left-hand-most chirality center. Okay, if we go to the right-hand-most one, again, chlorine, that's going to be our A, that's number 17. Hydrogen is D. Again, this carbon with 3 H's, this carbon with a carbon, an H, and a bromine. That one's going to be B and that one C. So A to B, B to C. That one is now counterclockwise. And again, H is behind where it's supposed to be. So this far one is going to be S. Okay, this one, again, bromine's A, hydrogen's D. I'm not going to write them. They are on the answer sheet, A and D. This carbon has a chlorine, an H, and a carbon. This one has fluorine, H, and carbon. The chlorine is 17. Fluorine is only number 7. So this is going to be B, that one C. So again, bromine A, this one B, that one C. So that direction is counterclockwise again, and our H is behind. So this one with the bromine is also S. Okay, this one, again, fluorine, that's the highest atomic number. That's A. Hydrogen's D. Right, we have a carbon with 2 H's, and then this carbon, a carbon with an H, a bromine, and that carbon. So once again, this one is going to be B. So we're going fluorine A, this carbon B, that carbon C. So A to B to C this way. Okay, that's clockwise, but here our H is in front. So clockwise, but H in front, you've got to assign it opposite. So that one turns out to be S as well. So it's R, S, S, S. For the 4. And again, the details of the A, B, C, D for the middle two are on the sheet as well. Okay. Naming. Okay, well, cyclohexane, and this is in the chair conformation. Okay, so it's cyclohexane. We have methyl groups, and there's 2 of them, right? So we know it's got to be dimethyl. Okay. If we number these 1, 2, 3, 4, or we could go around the back 1, 2, 3, 4. So it's 1,4-dimethyl cyclohexane. And someone asked about this a little earlier during the video chat. This one is pointing straight up. This one is pointing straight down. That's opposite. So this is trans. So trans 1,4-dimethyl cyclohexane would be the complete name for that molecule. Okay. This one, we have a chirality center. So we have 1, 2, 3, 4 carbons, so it's going to be some sort of butane on number 1, 2, 3, 4. On number 2, we've got a bromo, and that's a chirality center, so we've got to give it an RS. So again, this is A, the larger group's B, this is C, that's D. So A to B, B to C. That's clockwise, but again, the H is in front, so we have to give it the opposite, so that's going to be S. 2-bromobutane. Okay, so again, lots of practice at chirality centers here and a little bit of practice at naming as well. Okay, so last but not least, drawing some isomers. We haven't done this in a while. There are 4 isomers with the name dimethyl cyclopropane. So again, cyclopropane, that is a 3-carbon ring. Okay, and we know there are 4 of them. I tell you that, so we might as well draw 4 triangles to start with, right? So all of those are just plain cyclopropane. So now we need the dimethyl. And the difference between them is where the methyl groups are going to occur. Okay? So if both methyl groups are on the same carbon, that would be 1,1-dimethyl. Okay, cyclopropane. And no chirality centers there. Okay, we could have them on this carbon and this carbon. We could have it be 1,2. Okay, and now remember, on each of these, there's an up position and a down position. An up position and a down position. So if I happen to put both of my methyl groups up, that's going to be cis 1,2-dimethyl cyclopropane. And this one, like several of the others, the two halves of the molecule are the same, so that is a meso compound. Okay, so that is not chiral. So I'm sort of doing A and B together here. I'm putting the names down as well. Okay, well, if we have the cis, we also have trans, right? So if this methyl group stays up and H behind, and then on the opposite one, the H is up and the methyl is behind, that's trans. Well, this one, notice that the two halves are not the same. This methyl is up and that one is back. So I can draw the enantiomer of this one as well. So if I leave, so I need to switch each of the two chirality centers. So on this top one, the H is going to be up and the methyl down. And then here, the methyl is going to be up and the H down. Because remember, in enantiomers, right, you have to switch every chirality center to the opposite one. And this is also trans 1,2-dimethyl cyclopropane, right? So we then also need to assign the R's and S's to these two. So getting down to this third one, which of the molecules are chiral? The trans, this one and this one, are chiral. Those are a pair of enantiomers. So the trans molecules. Okay, those are a pair of enantiomers. So again, this trans applies to both. So we have to assign R's and S's. We're not quite done. So if we think about this chirality center, we have a hydrogen. That's obviously our D group. A carbon with 3 H's. Here's a carbon with 1 H and another carbon. This one is a carbon with 2 H's and another carbon. Okay, so this is going to be our A. That's going to be our B down here. This is going to be our C up here. So A to B, B to C, that's counterclockwise, right? Counterclockwise, and our H is down. So that one is S. And if we do the same thing here, it's this one. That would be A, the top one would be B, this would be C. A to B to C would be clockwise, but the H is up, so that one is also S. So this left-hand molecule would be SS, trans 1,2-dimethyl cyclopropane. Okay, the right-hand molecule, it better be RR if we've done it right. Okay, again, so we've got this. So if I look at this bottom chirality center, this would be our A, that would be our B, this would be our C, and then there's D. So A to B to C is clockwise, thank goodness, the bottom one is R. And the top one is going to be counterclockwise, but again, the H is up, so that one is also R. So again, these two you have to specify. The left one is SS, trans 1,2-dimethyl cyclopropane. The right one is RR, trans 1,2-dimethyl cyclopropane. And these two, the trans ones, the two at the bottom, are chiral. Those are enantiomers. This one is a meso compound, right? It is not chiral. There's no enantiomer. And this one has no chirality centers at all. So two of them are chiral, two of them are not chiral. Okay, so hopefully that explains this worksheet well.